Hi everyone and a warm welcome to the official YouTube channel of EDUSURE for your preparation of the UGC NET JRF Economics exam. So here what we will do, we will prepare you for the paper 2, that is the economics section in your UGC NET JRF exam, so that you get the flavor of the most important topics and the most important past year questions that you need to absolutely know for cracking this exam, for acing this exam, right? It is absolutely free of cost. So all you need to do is to subscribe this channel of EDUSURE UGC NET exam to never miss an update whenever we post an useful lecture video, right? Lecture videos will be covered. Also, the past year questions will be covered here, and we will talk about the most important parts because you don't have much time now. You have only 50 days. So we will touch upon the most important topics so that you get a wholesome flavor of what the exam is all about and how to approach this exam, right? So that is the agenda for this video. So I will be particularly covering your Unit 3 of UGC NET exam. Unit 3 is on Statistics and Econometrics. So let me show you the syllabus first. This is the syllabus of Statistics and Econometrics for your UGC NET, where you will see, firstly, you will have probability theory, probability concepts, probability distributions. Then you have sampling methods, sampling distributions, inference, hypothesis testing. Then you have some portion of descriptive statistics as well: mean, median, mode, central tendency measures, dispersion measures, correlation and index numbers. And then they have given you some portions of econometrics, particularly the linear regression model, simple classical linear regression model, their associated things, identification problem, simultaneous equation model, and a very small portion of the time series, discrete choice models, and the time series analysis, where they give you the where portion of the time series, where co-integration, these portions are covered. So that is the overview of the syllabus. So in this particular video, we will be covering the probability part. Basically, we will solve 25 most important questions that you will be getting from the statistics portion. Not only probability, from the statistics portion, I have seen and solved all the past year questions. And in the paid course also, you get all the video solutions. But here, what we will do, we will touch upon the important topics. We will randomly solve the most important questions that has come in your previous 10 years, right? So I'll be solving all the questions and I'll be talking about the associated concepts, right? So that is the way we should approach this session. So the first question, this is question number 1. Please take a look at this and try to solve this question. This is June 2023, recent question. It says, if S is the sample space and E is an event, then the probability axioms can be written as. What will be the probability axioms? Now, in our lecture videos, what we have discussed is that there are 3 definitions of probability. There are 3 ways in which you can define probability. So first one is the classical approach. First approach will be known as the classical approach. Second approach will be the frequency approach. Frequency approach, which is also known as the statistical approach or the statistical approach, right? Statistical approach. And the third will be the axiomatic approach. Axiomatic approach, right? So these are the 3 definitions of probability that we have discussed. In our paid courses also, we have discussed this thing. So in classical approach, what we say is that probability of any event, say A, if the event is A, how do you define the probability of that event? That will be simply, in the numerator, you will have the total favorable cases for that event A. All the favorable elementary events that are supporting this event A, and in the denominator you will have the all possible outcome. That was what, if you take this ratio, you will get the probability of any particular event A according to the classical definition of probability. But there are some severe problems in classical definition. What were they? If the number of outcomes, total outcomes, tends to infinity, then this classical model fails. Also, in the classical model, another problem was that we have assumed all the elementary events are equally likely. That is also not the case in real life scenarios. That is why these are the 2 major limitations of classical model. That is why we have to move to a more advanced method, that is the frequency approach or the statistical approach, where what we say is that for a random experiment E, A is the event associated with E. So how do you define the probability of A? Probability of A should be limit n tends to infinity Na upon n. So this is the thing which is the relative. Now this Na is not the favorable events. Na is not the favorable event. Na is simply the number of times the event A has taken place among the total number of possible times. Suppose you are tossing a coin 1,000 times. So this n will be 1,000. This n will be 1,000. Suppose among those 1,000 tosses, head has occurred only say 523 times, right? 523 times. So NA will be simply 523 if A is the event that head has occurred, right? So if you take this ratio Na upon n, you will get the relative frequency. This is the relative frequency. So in frequency distribution, probability is defined as the relative frequency in the long run, right? If you take limit n tends to infinity, it means the relative, you are measuring the relative frequency in the long run, that is n is going to infinity. That is how you define probability in the frequency approach. Finally, you have to go into the axiomatic definition because frequency approach also has some limitations of its own. What could be the limitation? The limitation could be we cannot prove that this limit always exists, right? The existence of this limit cannot be verified anyhow. That is why we need a more concrete approach, more mathematical approach in order to define probability. That is what is done by this axiomatic approach, which is given by Kolmogorov, right? Known as the Kolmogorov's approach. Now, Kolmogorov has given us three axioms. Kolmogorov has given us three axioms, which are known as the fundamental axioms of probability, right? Fundamental axioms which we use till date. This is the most sophisticated approach, most advanced approach, and this is what is used. The modern probability theory is based on this axiomatic approach, right? So the question here that is being asked in June 2023 is asking you about this axiomatic definition. What will be the axioms? What are the three axioms which was postulated by Kolmogorov in axiomatic definition, right? So this is the question. I have given you the context, the background, because that is the agenda for this video. I'll be explaining the associative concepts and solving the questions along with that. So see, S is the sample space, E is the event. So how will you define probability? So probability of any event should always be non-negative. This is the non-negativity axiom. This is the non-negativity axiom. So probability should always be non-negative. This is fine. Now the second is that probability of a sure event should always be equals to 1. If S is a sure event, the probability of that will always be equals to 1. And the third thing is saying that probability of union of this, which means that probability at least one of the events occurring, A1, A2, some events, at least one of them occurring will be summation of, can be written as the individual summation of all the probabilities. It is only true when the events are mutually exclusive. So there are three axioms. First is that probability of any event will always be greater or equals to 0. Second is that the probability of a sure event, suppose A is the sure event, will be equals to 1. A is the sure event. Let me write it in terms of S only. Probability of a sure event is always 1, and suppose A1, A2, up to AN, all these events are mutually exclusive. Mutually exclusive means they are disjoint in nature. They are all separate disjoint events. If this is the case, then how will you write this? Union I from 1 to n AI. So probability that at least one of them occurring will be equals to the individual summation of all the probabilities. Right? So these are the three different axioms that had been postulated by Kolmogorov, which is there in the axiomatic definition. So A, B, and C will be the right answers for this question. Now see why D and E are not correct. D says probability A is less than equals to 0. Can probability be negative? The answer is no. Probability of any event is a fraction, lies between 0 and 1, both inclusive. That is why negativity is not possible. And here see, they are dividing the sample space into different parts, but this is not there in the axiom. We only talk about the events. A is the event. See, A is the event which is associated, or E is the event associated. So this should be A basically, not E. This should be A is the event associated with that. So this event has to be there. We are talking about the events, not the sample space. That is why E is also not the answer. So what will be the right answer? A, B, and C only. A, B, and C only. This will be the right answer for this question, right? So here you can see the solution. I have given solution at the back of every question. and you will get this PDF in your Telegram channel of EDUSURE. After I post this lecture, I will be giving this in a PDF format, so you can take a look at that in your free time, right? So here you can see the solution. If you want, you can take a screenshot. All the things that I have explained to you is written, right? So this is the solution. Now let's look at this question. This is the next question, question 2, June 2024 paper, most recent year question. It says, in a random arrangement of the letters of the word violin, find the chance that the vowels I, O, E occupy only the odd positions, right? So this is a classic probability question. So let us see how to solve this question. So in violin, how many letters are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So there are 7 letters in the word violin. So if there are 7 letters, in how many ways they can be arranged among themselves? If there are 7 letters, here you have 7 letters in the word violin. In how many ways can these 7 letters be arranged? It can be arranged in simply 7 factorial ways. 7 factorial is simply 5040. So this is the total possibilities, total possible arrangement. Now, what is the favorable event? Favorable event will be the chance that the vowels here, there are 3 vowels. Vowels will occupy only the odd positions. Now, how many odd positions are there? See, this is 1, 2, 3, 4, 5, 6, 7. 7 positions are there. How many positions are odd? This is odd, this is odd, this is odd, this is odd. So you have 4 odd places, right? 4 odd places, and you have 3 vowels. So you have to place these 3 vowels in those 4 odd places. In how many ways can you do that? Firstly, you have to choose the 3 positions. From the 4 positions, you have to choose the 3 positions, right? This is the number of ways, total number of ways. That 4C3 is 4. That there are 4 ways in which you can do this. Into what is the probability that this 3 vowels will be, what is the number of arrangements? Suppose you choose this 3 options, these 3 places, 1, 3, and 5. Only these 3 positions are there. And then in how many ways you can arrange this I, O, and these 3 vowels in these 3 positions? That can be simply done in 3 factorial ways. So this will be the total arrangement, possible arrangement of the vowels only. See, this is 4 into 3 factorial is 6. So there are 24 ways in which you can arrange the vowels in the 4 odd places, right? Now there are 4 consonants as well. Total there are 7 letters. 3 vowels are gone. I, O, and E. These are gone. So V, L, N, T. There are 4 consonants also. And you have to place the consonants. Then you have 4 places, 4 even places, and you have 4 consonants. So in how many ways you can arrange them? They can be again arranged in 4 factorial ways, right? 4 factorial ways. So 4 factorial is 4 into 3 into 2 into 1. So again 24, right? Yeah. So again 24 ways, right? So these are the total arrangements for vowels. These are the total arrangement for consonants. So what is the total arrangement? What is the total arrangement? Total arrangement will be simply 24 into 24. The number of vowels into number of consonants, because you need both simultaneously. In order to comprise this word vowel, you need both vowels and consonants. So this is the total number of arrangement for vowels. This is the total number of arrangement for consonants. And altogether, how many arrangements are there? This is the total number of arrangements. So what is the required probability? The required probability will be simply this. We have to solve this thing. So let us do that. 24 into 24, 576 upon 5040. So this will come out to be 4 upon 35, right? So 4 upon 35, B will be the right answer for this question. So what I have done, let me quickly summarize what I have done. So in the word vowel, so what you see is that in the word vowel, there are 3 vowels and 4 consonants. Altogether, there are 7 letters, and 7 letters can be arranged among themselves in 7 factorial ways, which will give you the denominator. Now to find out the numerator means the total favorable event. So basically, you have to arrange the vowels in the odd places, and the rest of the portions will be comprised of the consonants. So firstly, if you have 4 odd places, 1, 3, 5, 7, in how many ways you can place these 3 vowels in these 4 places? That is 4C3 ways. Basically, you are choosing 3 options. choosing 3 places randomly from those 4 places. So that can be done in 4 ways, 4C3. Into the vowels can be arranged. There are 3 vowels. They can be arranged among themselves in 3 factorial ways. So this will give you the total number of arrangements for the vowels. Now for the consonants, the rest of the portions, 2, 4 and 2, 4, 6. These portions, these places, the rest of the portions will be 2, 4, yes. So these portions will be covered by the consonants, and those consonants can be arranged among themselves in 4 factorial ways because there are 4 consonants. They can be arranged in 4 factorial ways. That will give you the numerator. If you solve, you will get the required answer. So B is the required answer, yeah, for this. Right? I hope this concept is clear. This is June 2024 question. Again, this is the solution I have given you in simple words how to derive the solution. You can take a screenshot, or you will any which ways get this. Join the Telegram channel, you will get the PDF form, right? PDF version will be provided there. Okay. Now let's see the next question. This is December 2019 paper. And this question has repeated multiple times. I have only given you the questions where either the concept is very important, they can give you concepts, associated concepts, or the question which is repeated many times, right? I have focused on those questions only. So see, this is such a question, December 2019 and March 2023. So they have repeated this in 2 recent years. So it says, which of the following are correct in case of the area under the standard normal probability curve? So see, the options are given to you. Distance from mean ordinate in terms of plus minus sigma is this. The area is 0.55, odd area is 0.95. So these are the options that you have to find out. So what is the concept here? Let me first explain the concept. The concept is this. See this thing carefully. This is a very important property of normal distribution, which you have to remember that in case of normal, only normal, I'm not talking about standard normal. The question has asked you about standard normal. We will come to that. For a normal distribution, a normal distribution is always symmetric about the mean. Remember this thing. Normal distribution is always symmetric about mean, which basically means the area on the right hand side of the mean and the area on the left hand side of the mean is absolutely the same. Normal distribution is symmetric. There is no asymmetry in the right hand side, on the left hand side. Equal area is there. Now, if you take the first sigma range from this mean, what is first sigma range? You plus sigma with this mean, you will get this mu plus sigma. You subtract sigma from mu, you will get this. So if you are in this particular range, which is known as the first sigma range, from centering around mean, if you take this first sigma range, then the area of the normal distribution will be approximately 68%. So basically, if you draw this line and if you draw this line, you will get this pink shaded region here. So the area, total area of this pink shaded region is approximately 68%. So what we say is that mu minus sigma to mu plus sigma. This is the first sigma range. The area is approximately 68% for a normal distribution, right? Remember this fact. Now, what about the second sigma range? If you do this, mu plus 2 sigma, mu minus 2 sigma. So if you take this entire thing into account, you draw this line. So you'll get the blue region plus the pink region, or entire region here, and this entire region. If you take the area of this entire region, the total area will be approximately 95% of the distribution, right? So 2 sigma range, if you consider this mu minus 2 sigma to mu plus 2 sigma, this range, the probability is 95%. And finally, if you take the 3 sigma range, mu minus 3 sigma to mu plus 3 sigma, this entire portion, then almost entire area, entire probability lies in the 3 sigma range. That is this green portion plus blue portion plus pink portion. 99.73, approximately 99% of the distribution lies. Almost entire distribution lies in the 3 sigma range, which is one of the most important properties of normal distribution, right? So this will be 99%. So it's very important to remember this fact because many questions come. I've given you this 2 years, December 2019, March 2023, but they have repeated this question multiple times before also. So this 3 facts, these 3 points you have to remember that in the first sigma range, you have 68% of the total distribution. In the second sigma range, you have 95% of the entire distribution. And in the third sigma range, you have the entire distribution, almost more than 99% of the probability lies there, right? If you know this fact, you can solve this question easily because see, what is standard normal? See, here we are talking about standard normal. Standard normal is a special case of normal distribution only, where the value of mu is 0 and the value of sigma is 1, right? A distribution, if it follows normal 0, 1, we call it the standard normal distribution. So here, wherever you have mean the mu, you will put 0, and wherever you have sigma, you will put the value 1. If you do that, what will you get? So the first one will be -1 to +1. In the range -1 to +1, you will have 68% of the distribution. -2 to +2, you will have 95% of the distribution, and -3 to +3, you have 99% of the distribution. So the values remains the same, only the mean and the variance changes because as I've told you, standard normal is a special case of normal distribution. Normal distribution is x follows normal means the mean is mu, the variance is sigma square. But if this standard normal, then mean will only take the value 0, variance will only take the value 1. That is how you will get this range. And this is what is asked in your question. Now you have to mark the right answer. See, distance from the mean ordinance plus minus sigma. This is 0.5. So in the first sigma range, what is the probability? It is 0.68. 0.68 should be there. It's not 0.55. So this option is incorrect. Now see, if z is plus minus 1.96, plus minus 1.96 falls in which category? It falls in this category, -2 to +2. The probability is 0.95, probability is 0.95, right? So this is correct. Now the third option, distance from the mean in terms of z is exactly ±2. The probability is again 0.95, which is again true. The distance from the mean ordinate, this is 0.98. So 2.58 lies in -3 to +3. So the probability should be 99% and not 98%. So this option is wrong. And finally, you have z is ±3, which is more than 99%. This is also true, right? So this is the way you have to solve this question. You have to remember these three figures. So what will be the right answers? B, C, and E. So B, C, E. B will be the right answer for this particular question, right? This is how you solve this thing. You can again take a screenshot. You have to remember this thing. You can write it also in your notes that this is how it works, right? Okay. Now let's quickly move on to the next question and solve this. March 2023 paper number 2. So it says a card is thrown from a well shuffled pack of playing cards. Find the probability that it is either diamond or a king. So I have given you different flavors of questions. So firstly, I have started with the definition of probability. Right, the first question, if you look at it, is from the definition. I have explained you the concept of all the three definitions of probability. Next question is a typical probability sum that might appear. Any kind of questions like this might appear in your question, in your paper. Then I have given you the feature of the distribution, probability distribution, standard normal probability distribution, and then you have the probability question from the playing cards. 52 playing cards are there. So you have to find out a card is drawn. Either it's a diamond or it's a king, right? So how do you solve this kind of question? For that, you have to know what is the 52 cards. What are the 52 cards in a pack of, cards basically, well shuffled pack of cards. So here is the picture that you see is the 52 playing cards. This is the best way to understand this concept and to, so if you understand the playing cards well, then you can solve any question that we will give you from here. So see, here you have 52 playing cards. You have 4 rows. See, this is the first row, this is the second row, this is the third row, and this is the fourth row. In every row, you have 13 cards. In every row, you have 13 cards. All these rows are known as the suits. You have 4 suits, right? 4 suits, each containing 13 cards. 4 suits, each containing 13 cards. Now, this is the first suit, which is known as the club suit. All these cards that are there, all these cards in the first row will be in the club suit. The suit is club. There are 13 cards for that. The second is the spade. Second suit is called the spade. In this suit, you have 13 cards again. Then the third, as you can see, this is the diamond. Sorry, this is the heart. Sorry for that. This is the heart. This is the heart and this is the diamond, right? So these are the 4 suits. In every suit, you have 13 cards each. So altogether, 4 into 13 is 52. Altogether, you have 52 playing cards. Now, see here that in the first two rows, you have only black cards. In the first two rows, you have only black cards. In the next two rows, you have only red cards. So altogether, there are 26 black cards and 26 red cards. So questions also come that what will be the probability that it is red and a diamond, red and a something. Like question might be formed from that as well. So 26 black cards are there, 26 red cards are there. This is the first observation. Now see that in each of the suit, the first card that you have is an ace, is an ace. So this is the ace of club. This is the ace of spade. This is the ace of heart, and this is the ace of diamond. So altogether, how many aces are there? Altogether, you have 4 aces. Right? In a well shuffled pack of 52 cards, you have 4 aces. So in any question they ask you, what is the probability of picking up ace? Is 4 upon 52. 4 upon 52 in 52 cards, you have only 4 basically aces. Now from 2 to 10, you have normal cards, normal numbering 2, 3, 4, 5, 6, 7, 8, 9, 10. See, from 2 to 10, in every card, you have normal numbering. 2 to 10 is the normal cards. And then after 10, you have one jack. For every suit, you have one jack. So altogether, there are 4 jacks as well. Then you have a queen. So in every suit, you have one queen card. So 4 queens are there altogether and 4 kings also. 4 kings also, right? So this is the entire distribution, all the cards that you need to know. And this is the structure basically. If you have this thing in your mind, you can solve the questions very easily. Now let us get back to the question. So you have to find out the probability that it is either a diamond or a king. So if D is the event that the card is a diamond, suppose, and K is the event that it is a king. Now, can you tell me what will be the probability of picking up a diamond from this chart? If you look at this, what will be the probability? So as I've told you, in each of the suit, you have 13 cards. So in diamond also, you have 13 cards. So 13 out of 52 cards can be diamond. So you can pick up a diamond in 13 ways among the 52 total ways. So basically, we are using the classical approach only. In the denominator, you have all possible cases, that is all 52 cards. In the numerator, you have the favorable cases, that is 30 cards. Now, in the similar fashion, how many kings can be there? As I've told you, 4 kings can be there. Now, also, if you look at this, in the diamond also, you have a king. See this card. This is the common portion. You have diamond also, you have king also. So you have repeated them, you have included them twice. So you have to subtract this here. So diamond and king is 1 upon 50. There is one such card. So by the law of additivity, probability additivity law, so what you can say, what is the probability that it is either diamond or a king? This is what you have to find out. Or, this is or. Simply probability of diamond plus probability of king minus probability the intersection K. You have all the values 13 upon 52, 4 upon 52, 1 upon 50. So it will be 16 upon 50, right? So 16 upon 52, B will be the right answer for this question. And here you can see the solution as well. I have given you the solution. 16 upon 52 will be the right answer. You can take a screenshot if you want, or you will get this PDF anyway. Now let's quickly see the next question. This is December 2011. So I am running a little fast because you can basically, when you will see in your own pace, you can pause the video or you can increase the speed of this video. You can see this video in your own time, according to your own need. I am just going a little fast because I don't want to make it a longer video. So let's quickly see the next question. December 2011. Which of the following distribution functions has equal mean and variance? Now, in normal distribution, as I've said, normal mean is this, variance is this. Is it mandatory that mean and variance is equal? Answer is no. Mean may not be equals to variance. This is the most realistic scenario. In most of the cases, you'll see mean and variance are not equal. So this is not the case. In binomial, the mean is NP, the variance is NPQ. Are they equal? The answer is no, they are not equal. In hypergeometric, the expression is even more harder, complicated expression. I will show you that. You don't need to remember that, but they are not equal. They are not equal. The only distribution for which mean and variance are equal is the Poisson distribution here, right? So for Poisson, mean and variance both are equals to lambda. Now, if you see here, this is the chart that you can see. This is for the hypergeometric distribution. It's a complicated expression. You don't need to remember this. You only need to remember that they are not equal. So only for the Poisson distribution, mean and variance is equal, which is one of the most important properties of Poisson distribution, right? So here the answer will be option number D. This is December 2011, right? Now the next question is from index number, and this is the most asked question. I don't know how many times they have asked you this similar question, but this is their most favorite question. They love to give you this question. They have given you multiple times, multiple times. I have taken this question from a specific year, but this question is repeated at least 3 to 4 times. They have repeated this. Which of the following is an ideal index number? So, idealness of the index number depends on if it satisfies the time reversal test and the factor reversal test. There are these two tests which check the idealness for the index number, and only the Fisher's index number satisfies both the time reversal and the factor reversal test. That is why it is known as the ideal index number. So what is time reversal and what is factor reversal? If you see, let me show you the notes from our paid courses. This is from our paid courses. This is the note. You can again take a screenshot or look at this. That tests for index number, I've given you the screenshot exactly from the note. Irving Fisher suggested two tests for consistency of the price index. One is the time reversal, one is the factor reversal. What is time reversal test? Time reversal means index number is time consistent. How do you find out the consistency? Suppose for an index number, suppose 2015 is the base year and 2025 is the current year, right? Suppose this is the base year, this is the current year. And according to this, you find out an index number, suppose this is P01, right? This is the price index number, taking this 2015 as the base and 2025 as the current year. Now, what happens if you just reverse this? If you interchange this, suppose you make 2025 as the base year and 2015 as the current year, then the measure that you will calculate, it will look something like this. Now, if the measure has to satisfy, the index number has to satisfy the time consistency or time reversal test, it will mean that this measure will be exactly reciprocal to this measure, right? P01 and P10, they will be exactly reciprocal of each other, which basically means if you take the multiplication, this will be exactly equals to 1. So this is not mandatorily for only the price index. You can do this for the quantity index also. Sorry, this will be Q. So you can do this for the quantity index also. This will again come to be 1. So any index that you can do this for the value index as well. Value index as well. Any index number that you can think of. If you just reverse the time periods, base period and the current period, if you interchange them, they should be absolutely reciprocal of each other. If one is 10, another should be 1 upon 10. So if you take the multiplication, it will be 1. This is the concept, right? So this is what is the time reversal test. See here, you can take a look at this explanation. This is what I have explained. I don't want to read out this. Take a screenshot if you want. And the most important property is that Marshall, Edgeworth and Fisher both satisfies time reversal test. So this question is also again asked multiple times. Which index satisfies time reversal test but not the factor reversal test? The answer will be Marshall, Edgeworth. But here in the question, they have asked you the ideal index. For idealness, you have to satisfy both the tests. So the next test is the factor reversal test, which basically means the price index times the quantity index will be exactly equals to the value index. What is a value? Value is basically price into quantity. Value is basically price into quantity. So if you multiply the price index and the quantity index, if it is exactly equals to the value index, then you will say the index satisfies the factor reversal test as well. And only Fisher's formula, Fisher's is the only price index which satisfies the factor reversal, right? So basically what you can do, you can make a chart for yourself like this, that you have Pashi's index, you have Lashpier's index, you have Marshall-Edgeworth index, and you have Fisher's index. These are the 4 most frequently asked index numbers. And then you can write here the time reversal test, and here you can write the factor reversal test. So Lashpier and Pashi does not satisfy time and factor reversal. Please keep this in mind. It's very important. Neither Lashpier nor Pashi satisfy these time reversal, factor reversal tests. Marshall-Edgeworth, as I've told you, only satisfies time reversal test but not the factor reversal test, whereas Fisher satisfies both the time reversal and the factor reversal test. So if you remember this chart, this will help you in the exam also. This will come very handy. So please remember this, and answer will be Fisher. What is the ideal index number? Fisher is the ideal index number, and I've given you the concept also. This is how it works, right? Okay. Quickly go to the next question, December 2011 again. List 1 and list 2 you have to match. So in which situation you will use which statistic and which distribution. So when population mean with known variance, if the variance is known, what distribution you use? If the population variance is known, you will use the Z distribution, right? If the population variance is known, you will use the Z distribution. If there is unknown variance, you will use the T distribution. Comparison of variance. Comparison of variance can be done using the F distribution. There is nothing to explain. This is how they work. And goodness of fit can be measured using the chi-square test, right? So this will be the matching. So A is 4, B is 1, C is 2, D is 3. So C will be the right answer to this question. And here you can see the solution step by step. This is the same thing which I have explained. When reasoning is here. So when the population variance is known and the sample is large, you use the Z test. When the population variance is unknown and the sample size is small, you will use the T test. To compare two variances, we will use the F test. F test is basically the ratio of the variance. We will take ratio of the variance along with the degrees of freedom. That will give you the F statistic. We have to use F test there, and for the goodness of it, we use the chi-square distribution. Right? I hope this much is absolutely clear. If you have any doubts in any of the questions that I am solving, you can drop me a comment below. I'll reply to that. Right? So let's see the next question. This is June 2013 paper. It says let the two regression lines given as this and this. So regression line of x on y and regression line of y on x is given to you. Then the correlation coefficient will be what? So firstly, what you can do, suppose I write it in terms of this. Now, how do you find out the regression coefficients? Regression coefficients of y on x will be simply the slope. What is the slope? 3 upon 5. Why this is so? 3 upon 5x minus 10 upon 5. You can write this in this fashion. So this will be the slope. This is the slope regression coefficient of y on x. Regression coefficient of y on x. In the similar way, what you can do, you can find out the regression coefficient of x on y. So basically 15x will be 5 minus 4y. X will be 5 upon 15, 5 upon 15 minus 4 upon 15 into y, right? Okay, so here I have made a mistake. Sorry for that. Let me correct it. So 15x will be 4y minus 5. And x will be simply 4 upon 15y minus 5 upon. So what will be the regression coefficient of x on y? This will be simply 4 upon 15. Right, now you have the regression coefficient of y on x and the regression coefficient of x on y. So how do you find out the correlation coefficient? R square is simply dyx into dxy. This is from the property. So if you do that, 3 upon 5 into 4 upon 15. So 4 upon 25. So R will be, only the plus sign will be taken, because remember the property that if both the regression coefficients are positive, R will also be positive in sign. If both are negative, then R will also be negative in sign. So here you will take the positive square root only. So 2 upon 5. So 2 upon 5 is 0.4, right? So 0.4 plus, not the minus one. Please be minutely careful about this. Please don't write the minus sign. It will be positive of 0.40, right? So this is how you solve this question. This is option number B. Here you can see the solution. R will come out to be plus minus. So plus minus 0.4, but we will take only the positive sign because all the regression coefficients are positive. So 0.40 will be the answer, right? So this is about this question. Now let's move to the next question. This is June 2014. The arithmetic mean, the mode is given to you. You have to find out the median. So this question is asking you the empirical relationship among mean, median, and what we know is that mean minus mode equals to 3 times mean minus median. This is the empirical relationship among mean, median, mode. Put the values and solve for the value of median. So mean is 45, mode is 48, mean is 45, median is what we need to find out. So this 3 is gone. So what will be median? This will be simply 46. Right? Simple. 46. A will be the right answer for this question. Here you can see this is the solution which is given. Right? Simple question. Next question. In a frequency distribution, the standard deviation is given. The median is more than mean by 4. What is the coefficient of skewness? So coefficient of skewness according to Pearson's measure, if you remember, what was the skewness formula? 3 into mean minus median upon the standard deviation. So see, here I have given you the formula. You can take a look at this formula here. Pearson's coefficient of skewness based on mean and median, 3 into mean minus median upon the standard deviation. Now here see, standard deviation is given to you 15.8 and 3 into now median is more than mean. Median is more than mean by 4. So what will be mean minus median? If you write mean minus median, it will be minus. So this is minus 4 into this. Now if you calculate, let me see here the calculation. Minus 12 upon this will come out to minus 0.76. You can do this calculation, simple calculation, minus 0.76. A will be the right answer. So this is basically Pearson's first measure of skewness. There is another measure of skewness, which is the second measure. So where what you do, instead of this mean minus, instead of this, use this formula. So in first measure, you will use the right hand side, 3 into mean minus median as the numerator. But in the second formula, you will use mean minus mode as the formula. So nothing, they are the same. They are basically the same, only based on the information. If you have the information about mean and mode, you will use the second formula. If the mean and median is given to you, you will use the first formula. That is how it works. So this is the first measure, first Pearson's measure of skewness, and this is how you solve it. Right? This is the solution for that. Okay. Now let me go to the next question. This is June 2015. It says the mean is this, median is this, mode is this, then the distribution will be what? Positively skewed, negatively skewed, symmetrical, or none of the above. Now the best way of understanding this thing is to look at this diagram. Here I have given you, this is exactly from the paid notes. I have given you this. So in the note, what we have studied is that for a positively skewed distribution, mean is always greater than median is always greater than. Please keep this in mind. Again, this question is asked multiple times. We love to give you this question that for a positively skewed, this is how the distribution looks. You have longer tail towards the higher values of x. Longer tail towards the higher values of x. This is the positively skewed distribution. Here you can see how we have derived this thing. Mean, the value of mean is always greater than median is always greater than. For a symmetric distribution, for example, the normal distribution, mean, median, mode, I have told you that this here you will have mean, median and mode will also exactly be the same. So for a zero skewed, symmetric distribution means skewness is 0. That is why this is a zero skewed distribution, mean, median, mode, all three are equal. And for a negatively skewed, this is exactly the opposite, mean is less than median, less than mode, which is something like this. Right? So these are the 3 things that you have to keep in mind. Again, you can take a screenshot if you want. Now let's get back to this question. Your mean value is 26. Is it greater than median? Yes. This is greater than the median, which is 14. Is it greater than mode? Yes. The mode value is 7. So mean is strictly greater than median, strictly greater than mode. So it will be a positively skewed distribution. Right? So this is how you solve this kind of questions. Next question, June 2015. The question is asking for a normal distribution. Consider the following statements. It has 2 points of inflection and the distance from the mean to this points of inflection is plus minus sigma. What will be the answer? Answer is both of them are true. Both of them are true. So let me show you this diagram. This is the normal distribution. The normal distribution is symmetric about mean. In normal distribution, you have 2 points of inflection. One is for mu plus sigma and one is for mu minus. See, this is one point of inflection. This is another point of inflection. Inflection point means where the curvature of the curve changes. So see, here in this particular portion, what is the nature of the curve? Here the line is above the curve, which basically means it is convex in nature. And after that, the curve is above the line, which means it is convex. So it is going from convex to concave. And here the reverse is happening. So here you have firstly you have convex and then you have concave. So this is how it works. So there are 2 points of inflection which measures the curvature, change in the curvature of the normal distribution. It will happen when mu minus sigma at a point mu minus sigma and the point mu plus sigma. So the answer is here. See, the first statement is saying that it has 2 points of inflection. That is true. And the distance from the mean to this points of inflection is plus minus sigma. That is also. So both the statements are true. So this was June 2015. Now you have December 2015. The question is asking coefficient of correlation, that is simple coefficients correlation of coefficient of correlation is independent of which of the following? Is it change of origin only, change of scale only, change of origin and scale, none of the above? So what do you think? What do you think will be the answer for this part of this question? Can you tell me? Can you tell me this? Okay, so let me explain this thing. That correlation coefficient, firstly, it is an unit-free measure. Correlation coefficient is a unit-free measure which is independent of both the origin and the scale. Change in the origin and the scale, right? It is independent of both the change in origin and scale. How do you know this thing? So, for example, suppose x and y are the two variables. You change x as this, a plus b, say u, and you change y as this, c plus d, v. Right? You do the, this is the origin change. Origin change means you are adding or subtracting something from the variable. And this is the scale change basically. Scale change means you are basically multiplying or dividing something. Or you can take this in this fashion also. Let me define as the function of u and b only. So suppose u is x minus u by b and b is y minus c upon d. Right now, the correlation coefficient between x and y is rxy. You have to find out what will be the correlation coefficient of ru. Now, if you simplify these things and use the formula, what you will get is this: ruv will come out to be b into d upon mod b into mod d into rxy. You can, take this as your homework. I am not deriving this thing, but this is what you will see. So this ruv will be exactly equals to plus rxy when b and d are of the same sign. These two are of the same sign, and it will be minus rxy when b and d are of the opposite sign. So you can basically try to prove this. You will get this proof in any of your statistics books that you are using. It is a very, very well-known property that the numerical value or the correlation coefficient is unaffected. So only the sign may change. The sign can be positive, the sign may be negative, depending on this condition that the scale change, depending on the scale change. If the scale change is both of the same sign, then it will be the same value, exact same value. But if they are of the opposite sign, only the minus sign will come, but the numerical value will remain the same. The absolute value will be unchanged. That will be independent of the both the origin change and the scale change. So here, what will be the answer? The answer will be both change in origin and scale, right? So you can take this as your homework. You can try to prove this thing. If U is this, B is this, what is RUV? You can take this as your homework and solve this for yourself, right? And here I have given you this explanation again. When I'll upload this document, please take a look at this. Okay. Let's do the next question quickly. What type of relationship exists between the variables if all the points on the scatter diagram agree to fall on a straight line going upward from from left to right? So all the points are like this. Here you have x, here you have y. All the points on the scatter diagram are lying on the line, exactly on the line from left to right. So what will this be? This will be an example of perfectly positive correlation. Perfectly. So R value is exactly +1. R value is exactly +1 perfectly. So here you can see the relationship. Scattered plots, how do you identify the correlation using the scattered plots? Here I have given you all the possibilities. So this is the first possibility that they have asked you in the question, that all the black line, on the black line, all the points are there. So all the blue points are exactly falling on the line from left to right. That is the question that is been asked. This is perfectly positive correlation. Then you have, if there is slight divergence from this line, you will have highly positive, if not perfectly, but highly positive correlation. For example, it will be very close to 0.8, very close to basically 1 basically. Then if they are very much scattered, they are going from left to right, but there are distances between this regression line from the data points. Then you have low positive correlation. For example, it is very close to 0. So basically, the more you are closer to +1, the positive correlation, the more is the positive correlation. The more you are closer to -1, the more you are, closer to negative correlation. So if they are, you cannot find out any kind of pattern. They are, scattered here and there. If you cannot find any of the pattern, the correlation coefficient will be exactly 0. So scattered plot will help you to find out the correlation. Just by looking at visually, they help you to find out the correlation. And the Pearson's correlation coefficient numerically helps you to find out correlation, right? So if there is a negative pattern like this is low negative correlation. Then if the distances are low, but they are from left to right in this particular fashion, from upside to down, if they are in this fashion, there are high negative correlation. And if they're again, this is the extreme opposite of perfect positive, perfectly negative, they are exactly on the line from this point to this point. So here the R will be exactly minus, right? So this is all we know. So this is June 2020 recent year question, perfectly positive correlation. Okay, the next question is exactly from the lecture note that I have provided you. The chain weighted index number. What is chain weighted? Chain weighted means the base of the index number is also changed. So usually the index number that we study, Laspier's index, Pashy's index, Marshall-Edgeworth, Fisher, so they are all fixed base index numbers where we consider a year which is roughly a smooth year, which is, non-extraordinary year, the year which is not, marked by any particular event, any significant event, whether it is climatic, any sort of climatic event or financial event, any sort of no extraordinary things has happened in such an event. That is a kind of, year we take it as a base year. So in case of all the usual index numbers, we consider the fixed base index number. So we don't usually change the base. Base is changed once in a while. That is not very significant. But in case of chain weighted index number, base is changed in every period. If you continue to change the base in the successive periods, then it will be chain weight. So for example, suppose you are considering these 3 years, 2015, 2016, 2017. So 2015, suppose it is the base year. So when you will consider, you will find out the index number for this 2016, you will take 2015 as a base. But when you find out index number for 2017, you will take 2016 as your base, not the 2015 one, right? So the base here is changed from this to this. So for 2018, if you find out index for 2018, you will take 2017 as your base and not the previous. So that is why it is a chain index. Base year is also changing gradually. It's not fixed in nature. So what will be the answer? See, first option is saying the total market value of goods and service produced in each year. That is obviously not the answer. Percentage growth in real GDP? No. An index that measures how the prices of the goods including the GDP change? No. A method for calculating changes in the prices that uses an average base year of the neighboring year, that will give you the chain weighted index number, right? And here is the screenshot of the notes that we, teach in the paid course. I have given you this screenshot. You can take a look at this. I don't want to read this entirely. I've given you the concept. See, it is an index number calculated by linking or chaining together indices for each period to obtain the overall index value. That is what I have explained. It allows for the comparison of data over multiple periods using the index for one period as the base for the next. And this is the way you find this. I have given you an example also. You can just take a look at this, right? So this is done. Next question. Let's move to the next question quickly. March 2023. Question from Poisson distribution. Which of the following are correct in case of Poisson? So the first option is saying N number of trial is indefinitely large. Second is P, constant probability of success indefinitely large. NP is finite. Central moments. So firstly, what we know is that Poisson distribution can be found out as a limiting case of binomial distribution. Do we know this? Do we know this thing? Binomial distributions, limiting case will be Poisson distribution if certain conditions hold. What will be those conditions? First is number of trials goes to infinity. The constant probability of success must go to 0. So the first option is right. Number of tile is indefinitely large. That is true. Second option is false because see, constant probability of success, they have given it should be indefinitely large, but it is not the case. It should be indefinitely small. It should go towards 0. Third thing is that NP has to be finite. NP has to be a finite quantity, which is lambda. NP has to be a finite quantity. NP is the mean of the binomial. Lambda is the mean of the Poisson. So this three criteria has to be met. So if they met, then we can say that binomial distribution as a limiting case of, Poisson distribution as a limiting case of binomial distribution. So A and C is right. Now see, the third order central moment is exactly equals to M and not M plus P. For a Poisson distribution, third order central moment exactly equals to M and not basically M plus 2. Third order central moment equals to the mean. So in case of Poisson, the mean, the variance, and the third order central moment all are the same. So here lambda is exactly equals to M basically. And the fourth order central moment is this. This is fine. This is absolutely fine. So what will be the right answers? A, C, and E. A, C, and E, all three will be the right answer. So here you can see the explanation that Poisson distribution arises out of binomial. This is right. This is wrong. This is right. Mean variance all are equals to M. Skewness is this. Kurtosis is this. Central moment is exactly third order central moment is also exactly equals to the mean, which is also exactly equals to the mean. Right? This mean and the variance all three are equals to M. So this cannot be equals to M plus 2 is not there, but the fourth order central moment is right. So A, C, E will be the right answer. Okay. Now let's move to the June 2014 paper. It's again a question from dispersion and central tendency, a descriptive statistic question. It says which of the following are true in case of measures of dispersion and central tendency. First option is saying algebraic sum of deviation from the mean is minimum. So we know the algebraic sum of deviation from the mean is always 0, but it is minimum or not, we don't. So this option is incorrect by that logic. So the deviation, the value will be always 0, but it's a tricky part. Is it minimum or not? We don't usually prove this kind of thing, so we can consider it to be wrong. Second statement, mean deviation is least when calculated from median. This is a well-known property, very important property. You must remember this. This is true. Variance is always non-negative. This is also true. Mean, standard deviation, coefficient of variation have the same units. Is this true? Now, if you remember, while talking about dispersion, we said there are two measures of dispersion. One is the absolute measure, one is the relative measure. Mean and standard deviation comes in the absolute measure of dispersion, which has the units of measurement. But coefficient of deviation, what is CV? CV is basically SD upon mean into 100. So it is the ratio of two absolute measures of dispersion. So SD will have some separate unit, mean will have some unit. If you take this ratio, the unit will cancel out. If you take this ratio, that is why in relative measure, what we do, we want to make this unit-free measure. If you have seen the lecture video also, I have uploaded that lecture video. In the paid course also, I have also, given you the distinction between these two things. In absolute measure, the unit of measurement will always be there. And that will be same. The unit of measurement will be the same as given in the question. As given data in the question, that will be the same units. But in case of relative measure, we deliberately try to make it unit free because that helps you to compare between two or more distributions, right? That helps you to compare. That is why CV, since it is a relative measure of dispersion, it cannot have any units. That is why this statement is wrong. Mean median may have same units, but the coefficient of variation will not have any unit. It's a unit free measure. That is why the statement is wrong. Fifth statement is saying relative measures of dispersion are independent of the units of measurement. That is what I have explained. So this is, so what are the right answers? B, C, and E. B, C, and E, all three are true. Right? Here you can see the explanation. I have given you this. take a look at this, take a screenshot, and this is done. Next question. So this is January 2017 paper, which is a random sampling method. Random means probabilistic, right? Random means probabilistic. What is probability sampling? You have specific, you are attaching specific probability for each of the sample to be chosen. So is quota sampling random sampling? The answer is no. Quota means you have fixed number of allocated seats and you will take some of the samples according to that, according to your quota. Quota means you have fixed number of allotments, basically fixed number of people that you will take into account in your sample. So that is not probabilistic. Then you have purposive sampling. Is it probabilistic? Again, the answer is no. Purposive means you will deliberately try to include those people whom you think will give you response in your favor. So for your serving your purpose, if you're deliberately choosing from some people out of the total population, then that will be purposive sampling. Again, it is not random. Systematic sampling. Systematic sampling is a probability sampling. Why this is so? Because here we have a rule. So suppose every kth element, I will choose every kth element. Every kth people, I will choose. Every fifth people. So suppose I have 100 people in my population, I will choose, I have defined the rule that I will choose every fifth people. So fifth people, then I will choose the 10th person, then I will choose the 15th person all the way to the 100th person, right? So in this particular fashion, you will include the sample members. That is why there is a specific rule and there is a specific probability attached. Specific probability attached for choosing each of these sample. That is why this is a systematic sampling, is a probability sampling or a random sampling. And D is also right. Cluster sampling. Cluster sampling means depending on the nature of the sample, for some, homogeneous property has to be there in the sampling. The basis on that, you will divide into different clusters, and that is also probability sampling. So C and D both are probability sampling. The first one not. Here I have given you the explanation for that. Quota sampling, researchers select the participants non-randomly to fill a quota depending on certain characteristics. In purposive sampling, it's also known as a judgment sampling, where specific individuals are selected based on purpose or the characteristics. Systematic, every kth element of the list is selected after a random starting point, making it probability sampling. And in case of cluster, entire group of clusters are randomly selected, and either all or a sample of elements will be studied. So these are one-liner explanation of all the methods. And also I have given you this list. This is very important. See this list, sampling methods, probability sampling, non-probability. So these are the probabilities. So they give you this question, which of the following are probability sampling, which are non-probability sampling. So please remember this chart. Simple random sampling, systematic sampling, stratified, and cluster. They are the probability sampling. And non-probability is convenience sampling, quota sampling, judgment sampling, snowball sampling. They are the classic examples of non-probability sampling. Right? So this is about this question. Now the next question is June 2019, standard error. Standard error of the sample mean this will be X bar in a random sampling from an infinite population with replacement. If the sample is with replacement, then it will be simply sigma upon V10. Simple. But if it is without replacement, you need a finite population correction parameter. So it will be like this, n minus n upon n minus 1. Right? So this finite population character will only come if the sampling is done without replacement. So these are the only two possibilities. With replacement is simple formula which is asked here, sigma upon root n. Sigma upon root n. But if it is without replacement, this is the finite population. If FPC, finite population correction parameter, that will be also there. And this is the explanation given to you. Next question, it says June 2012, question from hypothesis testing. It says, for the regression model, this is the regression model. So alpha cap is given to you as 20, beta cap is given to you as 2. This is the estimated intercept parameter. This is the estimated slope parameter. Now you are testing an hypothesis that H naught, beta 1. So basically, let me call it beta 1 and beta 2. Let the intercept is beta 1 and slope is beta 2. So, oh no, sorry. This is basically beta 1. Let me call it beta naught. This is beta 1. So slope is this. slope is beta 1. So beta 1, you are trying to test that beta 1 is 2.1 or not, versus the alternative beta 1 is not 2.1, two-tailed test basically. Standard error is given to you, you have to calculate the t statistic. What will be the t statistic? Simple. It will be the estimated value of slope parameter minus the value of beta 1 under h naught. This is the usual way you find out test statistic upon the standard error of beta 1. Right, which under h naught, this will follow tn minus 2. So what will be the computed value? Firstly, you have beta 1 cap. Beta 1 cap is this, which is estimated value from the model. Then you have beta 1 under h naught. Under h naught, the value taken is 2.1. And then you have standard error, which is 0.46. Calculate this. I have done this calculation. See, 2 minus 2.1 upon 0.6 is 0.217. This will come out to be 0.217, and this is how you solve this question. So let us look at this. This is the model. Estimated value, standard error is given. This is the formula of t statistic, right? This is how you calculate the t statistic. Let us quickly see the next question. June 2013 paper. It says the chi-square test is used for what? Is it ANOVA, association of qualitative variables, difference between means from same population, difference between means from different population? So firstly, try to eliminate the option. So we know the difference between mean can be done by the t-test and the f-test. This we know. Difference in mean is nothing to do with the chi-square, right? Difference in mean has nothing to do with chi-square. So these two options are already gone. Now see ANOVA. ANOVA means, ANOVA, what we do, ANOVA is done using f-test. In ANOVA, we try to compare between the means of 3 or more groups, and it is done for the quantitative data. These are the 2 points you need to remember for ANOVA. First is that ANOVA is executed using f-test. That is the first thing. And second is that what we do in ANOVA is that using quantitative data, we used to compare the mean of 3 or more groups. 3 or more groups. That is done by ANOVA. So ANOVA is also not the answer here. So chi-square test will be used for association, checking the association between qualitative variables. Remember this, chi-square is used for categorical data. Categorical data. For categorical data, you use the chi-square test. What is categorical? Categorical means qualitative variables. Qualitative. For example, mother tongue. For example, gender. For example, race. So all these are not quantifiable. You will use dummy variable in order to, if you want to do them into the regression model. But usually they are quantitative in nature. Sorry, they are qualitative in nature, which means that they are not quantifiable. Mother tongue is not quantifiable. Gender is not quantifiable. So when you want to find out the association between quantitative variables of two groups, usually we do it for two groups, then you will use the chi-square test. Right? So chi-square will be used for checking association with qualitative variables, and ANOVA is used for quantitative data, and it can be executed by f-test. Also, it is used for checking. So basically, chi-square is only for two groups. Usually, two groups you want to check the association, but ANOVA is for 3 or more groups. Right? These are the distinctions. So here B will be the right answer. You can see this explanation here. I have given you why the other options are not true. That is also given. Right? Exactly what I have explained. Next question. Next question is December 2030. For 3x5 contingency table, chi-square value is given to you at 5% level of significance. Degrees of freedom for testing the number of associations are. So basically, degrees of freedom in case of chi-square test depends only on the dimensions of the contingency table. Remember this. If you want to find out the degrees of freedom for in association with chi-square test, it only depends on the dimensions of the rows and columns of the contingency table. So what is the formula? Simply row minus 1 into column minus 1. R is the total number of rows. Here, if it is 3x5 contingency table, what are the number of rows? Number of rows is simply 3. And what is the number of columns? Number of column is simply 5. So you write the row first and then the column. So 3 and 5. So simply put the values. This is 3 minus 1 into you have 5 minus 1. So 2 into 4. So the degrees of freedom will come out to be 8. Right? So 8 will be the right answer. Simple approach. You need to know this code. If you know this, you can solve this. So all the rest of the figures are not required. Chi-square value, computed value is not required. At what level of significance is not required in order to find out the degrees of it. They have given you just to confuse you. So only the dimension of the contingency table is given. And here is the solution. You can take a look at this solution. This is about this. Okay. Answer is 8, option number 8. Now, the next thing which I have explained just a few questions back, that June 2014, ANOVA is carried out using what? ANOVA is carried out using F-test. T-tests are basically used when the population variance is not known and you are working with the small samples. Z-test is used when you are working with large sample, population variance is known. Chi-square test is used, as I have told you, for categorical variables. When you are trying to find out the association between categorical variables, you use chi-square. If test is used for ANOVA for comparing means of 3 or more. So D will be the right answer for this question. See here, this is the same thing I have explained. You can take a look at this solution. Okay, so last 2 questions. This is June 2014 paper, matching list 1 and list 2. Given the information. So first, this is from type 1, type 2 error. This is checking your concept of type 1 and type 2 error. So understand what is type 1 error. Type 1 error means you are rejecting H0 when H0 is true. So it is a more severe kind of a mistake. If your hypothesis is true, but still you are rejecting it. This is a more severe problem. Remember that between type 1 and type 2 error, type 1 is more severe. So we always try to minimize type 1 error and then we go into other things, right? So our objective is always to minimize the type 1 error because it is more, consequences are more severe. So what is type 1 error? Probability. It is simply the probability of rejecting H0 when H0 is true or given H0 is true. That is the type 1 error. And type 2 error means failing to reject H0 when it is false. So basically accept H0 given that H0 is false. So these are the 2 things that you have to remember. The type 1 error, as I explained, type 2 means you will, both are the errors, both should not be done. If H0 is true, you should accept H0 and not reject it. That is why it is an error. And when H0 is false, you should reject H0, but you are accepting, that is also errors. But this is more severe, this is less severe. Now let us look at this. Rejecting H0 if which is true. What will be the answer? Type 1 error. Type 1 error is written as alpha, which is also the level of significance. Remember this fact that type 1 error is nothing but alpha, which is the level of significance. Right? So we basically make room in any kind of hypothesis problem. We make room for a little bit of error because we all are humans. We are prone to make errors. So to have that room for error, we include that level of significance. Before making into any conclusion, we say at 5% level of significance or at 10% level of significance. That is, we are making the room for that. That yes, there is a possibility of error. Only 5% error can be done. Only 5% chance is there that error is made. Basically like that, right? So yeah. So what I was saying is that, so type 1 error is nothing but alpha. So A will be option number 3, type 1. Type 1 error is alpha. Now B, accepting H0 when it is false is type 2 error. Type 2 error is known as the beta error. Type 1 error is alpha error. Type 2 error is beta error. So this will be beta. So B is basically 1. Now C, probability of rejecting H0 when it is false. So is it right statement? Is it true that we should reject H0 when it is false? The answer is yes. When H0 is false, we should reject H0, and that is given by the power of the test. That is known as the power of the test, and power of the test is 1 minus probability of type 2 error, which is 1 minus probability of type 2 error, which is this. So C will be option number 4. Right, these we all know. I guess you all know these things. Type 1 is this, type 2 is this. Power of test means 1 minus probability of type 2 error, which is 1 minus beta, which basically means probability of rejecting H0 when it is false. The greater it is, the better it is. The greater the number, the greater the probability, the better it is, because that is what it should do. Power means how good your test is. That is the power. And the final thing is that Measuring sample variability due to random forces, that will be given by the standard error. So this will be the matching. Let's see, A is 3, B is 1, C is 4, and D is 2. So D will be the right option. So see here, given you the list, you can take a look at this list. So D will be the right answer. And I think this is the final question. We'll solve this and then we'll stop for today. So June 2021 paper, sequence in econometric research. What will be the sequence? Data collection, policy prescription, hypothesis testing, hypothesis formulation. So before starting the research, first thing is that you have to define the research question in any kind of research that you do after clearing UGC NET. So basically what you have to do, firstly, you need to be very concrete and clear about what is your research question. What is that you want to find out? What is it you want to research on? So that research question has to be defined very properly before going to anything else. So the first thing will be hypothesis formulation, right? The first step will be hypothesis formulation. That is the base of any research. So in the first year, what you do the literature review, and then you come up with a valid question. That is what you do. You basically study whatever is being done in your topic, and then you define a problem for yourself, right? So that is the hypothesis formulation. So option D will be the first portion. Option D will be the first thing. Now next, when you know what is the research question, the next aspect will be to collect the relevant data in order to test that. In order to find out something, you need to then collect the data. So this is the second part. Second is A. The third part will be when you have the relevant data with you, you will test the hypothesis and you will try to check whether your hypothesis is right or wrong. So that will be option number C. And then finally, depending on the results of the hypothesis testing, you will prescribe some policy recommendation. So B will be the final thing. So this is the correct order. This is the correct sequence of econometric research. So first is formulating a question. Then is you have to collect the data, particular relevant data, depending on the question that you have defined. Then you have to test the hypothesis. This will be the third portion, and then you have to prescribe the policies and the real life applications basically of the conclusions that you have, the results and the insights that you have derived through your research. Depending on that, you will derive policy prescriptions, right? So these are the four broad steps that you have to follow for econometric research. So C will be the right answer, and here you can see the solution, right? So this is all from my side for this video. We have solved 25 most important questions. I have touched upon statistics, both the descriptive portion and the probabilistic portion, also some few parts of econometrics as well. Though we will continue with econometrics the next day. In the next video, we'll again take up 25 questions and we will see some more important concepts, right? I hope you like this video, you find this video helpful. This is a kind of revision session, right? Not many days left for your UGC NET now. So this you can treat as your revision session. I hope you like this video. If you find this helpful, do subscribe to this channel of EDUSURE UGC NET exam preparation. This is exclusively made for your UGC NET preparation. So support this channel, subscribe to this channel, do hit the like button. And if you have any doubts anywhere, you can let me know in the comment section and I'll answer to that, right? So thank you so much for attending the session, and let's meet you in the next video. Thank you so much.